Hello, welcome to the fifth episode of creating a chain reaction game with the Godot Engine. In the last episode, we tackled the whole mechanic of this one, which is replacing the spheres according to the data layer, what it's getting changed. So it was working very fine. So now what we need to do is we need to add the animations to this layer, so that there will be a smooth transition when the split happens. So first we will to do the animations we will use a node called tween, right? So this tween node, you can just go to the two spheres, because we don't need to animate the single sphere. The single sphere will never split, right? Well, how will it split? So you need to have a two spheres, and the two spheres will split it into two different right angle directions like this. So just go to the two spheres, select the two spheres scene, just Control A, will add something called as a TWEEN tween. So as you can see, the description is smoothly animates and nodes properties over time. So we'll select that. So we will need two tweens, so just duplicate it, so one for each of these spheres mesh instances. So in order to set the properties of the tween and tell it what to animate, how to animate, all that stuff, we will have to attach a script to the two spheres itself. So select the two spheres, attach a script. So this will be a generic script which will be attached to all of the types of spheres, that is two spheres, three spheres and four spheres. So these three kind of spheres can actually split, right? So that's why we will be attaching the same script. We'll be saving some memory. We don't need to create three scripts for each of them. So I'll just name this spheres.gd and I'll hit create, and now this will be an empty.gd file. So now what we'll do is we'll just make a new function. I'll just name this as run split animation, run split anim. So pass. So this will be a new function to actually run the animation. So we first shall create the tween nodes for all of these first. So go to the three spheres, add similarly to the two spheres, add a tween node, just duplicate it twice, and again go to four spheres, add a tween node and duplicate it thrice, not thrice, okay, that's four times. So save these scenes, and then attach the same script. To attach the same script, go to the three spheres, attach the script, just give the same name as it was there. So you can see script file, it create a new script file is the status. If we do this, it will find an existing script with the same name, so it will tell it to load the existing script file. So cool, I load the same script over here, and then the same thing we'll have to do for the four spheres as well. Name the spheres and load. Okay, cool. So if you go to the two spheres, we need to distinguish between if it's a two sphere instance or a three sphere or a four sphere, right? Because we need to do the animation only for the two spheres over here. Into animation for three spheres, we need to distinguish them. So one of the ways to do that is just to get the count of the children over here. So this has 4 children, this has 6 children, and this has 8. So just go to run animation. So just to get the children of the nodes, the number of children below the node which the script is attached to, so you can use the function self dot, I think it's get child count. Yeah, get child count will get you the number of children over there. So if this is equal to 4, that means we are in the two spheres. So if we are in the two spheres, First we need to set the properties of these tweens. So to do that, just reference the tween, $tween dot, there's a function called as an interpolate property. So this is a very long argument list, so I'll tell you what each of them does. So the first property is the object itself, the object you want to animate. All right, so that will be the mesh instance. So tween will animate the mesh instance, and tween2 will animate the mesh instance too. So the first one is $mesh instance, we'll reference that, and the next one is the property, node path property. So the property of the mesh instance is translation that we need to change. So just make sure you type this properly, it won't give an auto completion for this. So the third argument is initial value. So this will be a new vector3 from the origin, and then the next argument will be a final value. So that this is straightforward, and it will be probably, let's assume it's 1 unit to the x-axis, so 1, 0, 0. And then the next argument will be if I just hit tabs, you can see the next argument is the duration of the animation. So I just set this to be 0.5 seconds, I think that is good. And then the next one is a transition type. So this refers to whether the transition is linear, that is just start from the point and just go in a constant speed, and then whether it is sine, whether it is quad, so whether it is elastic, it will go and bounce after reaching that point to just stay in that point. There's a function called sine as well, which starts in slowly and then smooths out at the end. So there are different transition types. So I think the most appropriate one will stick to the actual game chain reaction. So they just use a linear animation. So tween.transLinear is what we'll choose. So the next is an additional smoothing parameter on top of the translinear. So as we just need we are not using a special one such as sine or quad, so it really doesn't matter what you choose here. It is not doing any easing, so I just choose is in out for now. So this will be the whole function which sets what properties that tween is working on. So I'll just copy paste it for the tween2 as well. So this will be working on mesh instance 2, and then one thing that we need to change is, let's make this end value in the z axis. All right, after doing this we need to start the tween, so we need to start the animation itself. So to do that, reference it by $tween dot, there's a simple function, straightforward function that is called start. So the tween will start interpolating this property of this object from this position to this position with this time. So these are all the parameters that we are giving, so it will get started when we call the start function. So the same thing will start the second tween as well. So actually we'll just call the run split anim in the ready, just for testing purposes. We'll just test whether this animation is getting done. So I also observe that we don't actually have a camera. So if you remember in the first episode, I told that we need to have a camera to actually render the 3D world, right? So we don't have a camera over here. So if we just hit play, we'll just get a gray screen which is rendering the 2D space, right? So what I'll do is just temporarily I'll just add a camera to this, and I'll move it back like this, move it up, and then just use this red handle to look at the sphere, and I'll hit the preview button to actually see what the camera is looking at. You can switch it back. So this is the camera. So now I'll just hit play. Let's see what happens. so it is not animating. So why is that? So I got the problem right away, because when you added a camera, this actually increased the children count to 5, right? So we actually checking for a children count of 4. So this for now will increase it to 5, and then we'll test play. So now you can see they animated, they moved, right? So just play that again. They just moved from their place and they split it into two different in two different directions. So this is clearly working, so I'll just delete the camera and then turn this back to 4. So after doing this, we need to do the same thing and just check else and paste, and check the same thing. If there are 6 children, that means that we are present in the 3 spheres node. So I'll just copy the second one and then paste it. So for this I will be ending the third one in -1. So let's say x is +1 and y +1 and z is -1. Let this be 0, so it doesn't go in a diagonal. So $tween3 dot start, we'll have to call the start function. So I'll copy this whole thing and then just paste it. So this will be for the 4 spheres. Yeah, I have to change this to tween3 and mesh instance 3, and this as well, mesh instance 3 tween3. Just triple click selects the whole line, and then I can just go to the edge and paste the whole line here. So this will be tween4, working on mesh instance 4, and then the end will be the remaining one, that is -1. So this will split in all the 4 directions. I'll copy the tween3 and rename this to 4. So now basically all the animations should work, right? So after we do this, so I think we can just go over here and hit play. So I'll first go to the 2 spheres and remove the run split anim function over here. So we need to call this run split anim from somewhere else in the chain reaction first to actually execute it, right? So where can we do that? So I think after replay sphere, we are actually doing a mistake over here, because we are actually straight away calling the replay sphere, which changes it to another instance right away. So we need to do all of this. So we need to call the replay sphere only when the animation ends. That means after it has reached the end point, then only we have to add. So there are many ways of actually tackling this. So the one method I did earlier in my reference is just using a timer. So that timer will start whenever we change the data layer, that is when we explode, and it will complete whenever we just want to replace this sphere again. Right, so I'll just check for what is happening over here. So just create a timer node over here. So go to the chain reaction, okay, go to the chain reaction, Control A, hit timer, and this will be a kind of node, just very handy to actually just use the start function to actually start the timer and then just end. So I was just struggling very hard to actually code timer functions in Unity game engine back when I was working. So it would be a lot convenient like this if it had a timer, because these are some of the primitive things that you will use in a lot of places in game development. So you will have a timer for respawning a player, you'll have a timer for like delay, animation delay, you will use it for so many things, a lot of things. So this is a lot an essential part. So I'll just rename this to explode timer. I'll set the wait time, that is the duration of the timer, to 0.5, so which is the exact same time as we gave the animation over here. Okay, so now what we have to do is so we have to run the split animation, right? So I think just go to this explode function, and after I guess before just implementing, I'm just checking my reference of how to get over this, because what we are doing is we are just calling the animation, and after we complete the animation we need to delete the animation dummy sphere that we used for our animation itself, and then we have to replace it with whatever was there. We have to call the replace sphere function that is over here to actually update that animation, not the animation, update the sphere which is going to be spawned at the end of the animation. So to do this, first what I'll do is, when we explode in a corner, right, so when we do this, I will make a new instance of a 2 sphere, because this is this dummy sphere that we are using to show the explosion animation, because when we click on that, when it explodes, we actually need to spawn a 2 sphere over there and then play that animation so that it actually goes into the it actually splits. So I just call a new sphere.instance over here, and then I will add this to the scene. So add child s. So this is a shabby way, so I just create a new spatial node. I'll just call spatial. I'll just call this as explosions. So this will keep track of all of the explode, all of the animations it'll have. So this will be added to explosions dot add child s, and then after this we'll have to set the translation as well, right? So translation will be equal to the same thing. So I'll just go down, just copy this s.translation, and then go up and then just paste it over here. Again, instead of hitting Ctrl C, I hit Ctrl V, I hit Ctrl C. So cool, it is going to be spawned in the right place. So now we need to run the animation properly. So I will just we can go ahead and run the animation now. So to do that, we'll have to run it on s itself, s dot run split anim. So that means in this dummy sphere the animation will be run. So after this is done, we can decrement the board data, and then we can, I guess, call the replace sphere function. So yeah, we'll do this step by step. So we are creating a 2-sphere instance, and we are running the animation itself, and then we need to decrease. And now what we will do is just call the replace sphere, because after this happens, the board data of the current space will be 0. So we need to update that right away. So just so I will just check whether I'll just make a chain of conditions over here. So it'll be, if the board data of pose.x and position.y, if this is equal to 1, we need to call the replace sphere with the 1. Is it? No, no, we are actually doing that. So I'll just cut and paste this over here, right? So we'll update the visuals after we replace the sphere. So after we do this, let's just start the explode timer. So just the same way as the tween, we'll use the start function. So what can happen is we need to do a yield over here. This needs to wait for an animation. So yield for the animation complete. So if you have not used yield in programming before, it is just a function that if you put it in a condition or anywhere, so the execution will stop unless the yield condition is true. So it will look for something every frame that we pass into the yield function. It will look for that signal every frame, and then if that signal is true, then it will continue the execution of the rest of the program. So that is really handy to actually stop the execution over here. So wait for the animation to complete, and then update the board, update the spheres respectively. So the yield function in Godot takes in a signal. So we need to create a signal. So go to the top and then just create a signal, signal. I'll just call this splitter complete. Okay, so this signals in Godot is just like a callback in any other programming language. So the signals are, they you don't need to do polling of some variable. So if a condition is true, we can just send out a signal to any other object, any other node in the engine, and then call a function on that node, or we can do whatever with it. So this will be very similar to a callback. So emitting of a signal, there's a function for that, and then handling the signal. So a signal is basically all of the callbacks that are associated with the object itself. So if we as you can see, we have created a new signal called splitter complete. If you go to the chain reaction node, go to the signals over here, you can see that the signals of the script are visible here. So on splitter complete it is visible. So when this timer gets exploded, so when the animation is essentially completed, the timeout signal will be sent. So it will be true, so I'll connect it to a new function in chain reaction itself. So I'll just let it be the default name, and on explode timer timeout, so we need to emit the signal, another signal, which we called as splitter complete. So that's over here. So I'll just emit the signal, and now what we need to do in the yield, so I'll go to the explode function over here, and then in the yield, which is over here, so just call the yield function. So the first parameter will take in the node itself, which is our own node, so it's expecting a signal which needs to be completed. So that is not these inbuilt ones, it will be splitter complete. So this line will actually stop the execution until this signal is true. Okay, so after we start, we'll yield it after the explode timer gets completed. So this same thing, we have to do it for all of the nodes. So I'll just test for this node. I just hit on the corner button. I just hit the corner one over here, it gets spawned, and now when we press on this, you can see that the animation is getting played, and indeed after the animation got played, these two spheres are getting spawned. Cool. So you can take a just look at that again. So when we click over here and then we click again, the animation plays. So the direction is not proper now, it is getting played. So after the animation plays, the yield is actually stopping the execution, and then it will create the two nodes. So there are two things that we need to do here. So the first thing is rotating this whatever, so it is actually splitting in the right directions. And then the second thing is deleting these objects. So we don't need that objects because we are spawning two new instances over here. So I think the latter one is easier to do. So we'll go to the two spheres. These tweens, they also have a signal. So as you can select the tween over here and go to the node tab, you can see there's a signal called tween completed. So we'll connect this signal. We need let it be the same. So in the same script we have made the on tween completed. That means after this gets completed, we need to delete this whole dummy object. So this whole object which starts the tween itself is actually a dummy one because it's only used for the animation. After the animation is completed, it should get deleted, right? So because we are actually spawning a new type of sphere at the adjacent places. So in this tween, we just call the function queue_free. That means delete this whole object. So it's okay only to just call it for one of these tweens because both of them will play simultaneously over here, right? So even one of them calling queue_free is fine because this whole object will get deleted. So we'll do the same thing. So for the first tween, the tween completed, connect this signal, and the function has already been implemented. And then again we'll do the same thing, select the tween completed, connect the signal and connect. So again we'll save all these scenes. You don't need to save it. When you actually hit play, it will auto save all of the scenes at once, so that is also good. The next thing that we will do is copy this whole thing and then place it for this one, the edges. So yeah, before doing that, I told that we will have to tackle the rotation, right? So first let's do that here itself. So what I will do is we need to rotate this object. So I'll go over here and I'll take in another argument called rot for this function. So that means that you need to rotate this whole object by whatever degrees. So now it's fairly simple. So we will we'll rotate the whole two spheres object itself. So rotation degrees, we'll mouse over this, so we'll get the hint that the property name is actually rotation degrees, rotation underscore degrees. So we can access that. Rotation underscore degrees is equal to rot, or I guess rotation underscore degrees is a vector 3. It has 3 spaces, so we'll assign only the y component because it has to rotate about the y-axis to actually change the direction. So after we go over here, we'll go to the chain reaction. Now again we need to do the subconditions just like we did in, so where did we do the subconditions? Yeah, in explode itself. So here, down here, I'll just copy all this, go to the top. Yeah, we have to do it here in the run split anim. I'll just paste it over here, delete all this, delete these, and I'll just delete these like this. And now what we need to call is S, that is the instance of the two sphere dummy one, dot, what was the function name? I forgot. It is run split anim. Okay, run split animation. So it takes an argument. So I also saw that it was splitting to the right and the above, right? So when we are in the top right corner, so we don't need to do any rotation if it's in the bottom left corner. So that is this case. So I'll just copy this and paste it. So we'll just see if it's in the left and the bottommost. Let's just rotate it clockwise by a 90 degrees. Let's just assume this works. So if it's not, it's a very simple fix. I'll just come back over here and then just change the values. Cool. So I'll hit play. I'll check for each of the corners now. So okay, this is not proper. So I think the one in the 0 is proper. Yeah, this is working fine. So if it's in the top right corner, it is going to the left. So if it's in the top right corner, we need to rotate it by 180 degrees. Not 180 actually, we need to rotate it clockwise probably. So if it's here, we will just assume it is 180 and then we'll check. Now this is working. So this obviously needs to be 270 and this should be 90. So I'll just check. This is working, this is working, this is working, and this is working. So the rotations are all perfect in this case. So what I will do is in the next episode I'll just copy all this. So I think I can do that now itself. Just copy these and then go over here, paste it, just replace this one. We'll be minusing this by 3. So this will be a 3 sphere instance, right, when it's in the edges. Okay, so the same thing we need to do. So these will be changed and call the replace sphere. So that is all right. So we need to copy this whole thing and then just paste it over here. And then we also need to do the yield and the explore timer start over here in the edges cases as well. So after we, I think it's after we replace the sphere, right? So yeah, after we replace the sphere over here, so I'll paste this, yield it. So I'll remove all these. This is for only calling one function, that is, what was it again? Rot split anim, right? So yeah, rot split anim. So rot split, oh yeah, this should be called on s dot rot split. No, it is not rot split anim, run split anim. Runs the split animation of, if it's in the leftmost, I'll just assume it as 0. So these are just assumptions for now. We will tweak the values later. So just copy the same values. This should be 270. I'll just assume this works fine. So I'll just hit play now. There should be no errors. 2, and then if we do 3, okay, this is working. This is obviously wrong. It should be rotated by, if it's in the up, we should rotate it by, I think, 180. So again, if we do this part, the right should also be changed, which is this one. So if this is 180, I think I'll make this as, I'll make this as 180 and this as 90. Let's see what will happen. So now in the left it's working fine. If it's in the right, it should be replaced by 180. If it's in the top, it should be replaced by 90. It's working. So again, if it's in the bottom, it is rotated by 270. So you can also see that the splitting is also working, but the 4 places that we split is instantly updating. So I'll just copy this whole thing again, go over to the place where we do the 4, do the middle places. I'll just change this to 4, space.instance explosions.add child. So anything else? So we actually don't need to do the whole of this because we are splitting in all the 4 sides. We don't need to rotate, right? So run split anim, I'll just give 0. So again, replace the sphere, explore timer, and then split. So the game should basically be done almost. So we will see if there are, oh, there is some error. We are actually something wrong with the animation over here. As you can see, this is -1, this should be 0. So when you go to the chain reaction game and hit play, this should basically be done. We'll just spot any errors that we get. It's splitting fine. This also is getting added. So we'll see the chain mechanic as well, like this. So this is really good to watch, right? Look at that. Whoa, nice. So the basic mechanics are done. So the next things we need to actually look upon is making the turn based. So we need to change the color of these spheres for each of the players' turns, and also we need to change the color of the grid itself. So in the actual game this happens. So we'll be tackling that in the next episode. So until then, if you have any doubts or any thing you want to share, you can do that in the comment section below. So until then, I'll just be playing this game just like this. It's just so fun to actually play. See you. Bye bye. See you in the next tutorial.